Hello and welcome to the start of P2, and this lesson we are looking at static electricity, which is the first lesson within topic 1 of P2. Okay, so basically just going to go through some fundamentals, what sort of things we're looking for, etc, etc. So things we're going to cover first of all are what causes static. Okay, so I'm hopefully going to go through this step by step. Number 2, it says example of static in use. So static, where can we see it around us, and then uses and dangers of static electricity. Okay, so if we go slide by slide, you'll see what's going on. So what causes static electricity? Well, first of all, you need to look at the fundamentals of the world around us, and here we have atoms. Okay, apologies. So atoms, basically, you should know that are made up of protons and neutrons. And the thing that we're concerned about with is the little things that spin around the outside, and these are our electrons. Now, electrons have a negative charge, okay? And this is really important when we look at static. Okay, so when things become statically charged, what happens is the electrons transfer from one object onto another. And how they transfer is by friction. So in this instance, we've got the classic rubbing the balloon there. Imagine I've got a balloon and rubbing against my head, okay? So what's happening therefore is I'm transferring electrons from one object to the next object. So if I rub the balloon, the electrons are now transferred to the balloon. Okay, this means that the balloon has now got a negative charge, and the person's hair would have a positive charge. Okay, they have equal and opposite charges. Okay, that's important to remember, equal and opposite charges. Okay, now what's going on in these two pictures here? So both of them was trying to charge, put some static charge in the two rods. On the side here we have the metal rod, and on this side here we have a plastic polyethylene rod. Now, as you can see, that the polyethylene rod has got a negative charge here and positive charge on the cloth. And the same is happening here, so they've got positive on the cloth and negative in the rod. But with the metal rod, because metals are, as you hopefully know, are conductors, the electrons are free to flow through the rod. Okay, so the electrons flow through the rod here and onto the person's hand, and then the electrons flow out into the ground. Okay, I'm going to talk about that a bit more in a bit, but this is what we call earthing. Okay, but static only occurs in insulated materials because here the electrons are not free to move as they are in the metal rod. Okay, so where do we see static around us? Okay, so this is a basic practical you can do in the lesson where you statically charge up two rods. Okay, so if you were to bring those two rods together of different materials, one being positive and the other one being negative, they would attract, and then the opposite would happen if they were the same charge. So they're both positive, repel, both negatives, they would also repel. Okay, so examples you've got here are acetate rods and polyethylene rods. So if you use friction by rubbing the cloth on the rod, what happens is you have electrons transferred to the cloth in the acetate, the opposite happening here in the polyethylene. So the electrons would be transferred to the polyethylene rod, causing the polyethylene rod to have a negative charge and the cloth to have a positive charge. Alright, so then some practical examples of why it would happen. Why is it that when you rub the balloon becomes negatively charged? Okay, why does it then allow the balloon to stick to the wall? Well, what's happening is that the wall itself is full of positive and negative charges. So when you bring the balloon into contact with the wall, what happens is all the positive charges in the wall are attracted to the negative charges in the balloon. Okay, so this strong attractive force here causes the balloon to stick to the wall, and it repels the negative charge in the wall. Okay, again, this can be done with a comb and a piece of paper. You charge the comb up using friction again to remove the electrons. Remember, it's not the protons that move, it's the electrons that move. Okay, and then again, you could pick up the paper where the negative charge is attracted to the positive charge and pushes away the positive charge within the piece of paper. Okay, and now we move on to the last part, which is the uses and dangers of static. Okay, so I'm going to go over this more in class, but obviously static electricity is still electricity, and it can create a spark. Now that spark can be used to light a fire, and like I said, we're going to look at that bit more in depth within the lesson. Okay, but uses, right? So what we can do is we can statically charge paints or different sprays depending on what we want. So in this instance, sometimes when we paint items, what we do is we statically charge the paint droplets, okay, and then we give the opposite charge to the object that we want to paint. Okay, so in this instance here, we've given a negative charge to the bike frame and the positive charge to this paint spray. So you might be thinking, how do we give a positive charge to the paint spray? Well, what we do is when it comes out the end of the nozzle, okay, there's friction there, so the friction is causing the electrons to be stripped from the paint, giving it a positive charge. Now obviously this has a double effect, because the positively charged spray, okay, what it does is then it repels each other, so it covers a large area, but it also then covers the bike frame because it's attracted to the bike frame, so giving a nice even cover to the bike frame. Okay, another example, we can use them in inkjet printers. When the ink leaves the printer, it has a negative charge. Again, this can be done using friction on the paint droplet. Now there's two metal plates, and one's positively charged, one's negatively charged. And obviously the printer, what it does is it can change the size of the charge. So if it increases the charge on the positive, okay, then the negatively charged paint droplets are attracted towards it, and again vice versa. Okay, and that's pretty much it. The only other thing I really wanted to show you was, bear with me, we are nearly there, we're doing great. Okay, last thing I want to look at is this. Here's our what we call a Van de Graaff generator. Okay, I'm going to look at this in a lesson. Now what it does is cause your hair to stand on end. So what I want you to think about is, how does it cause your hair to stand on end? Okay, alright, thank you for listening.